and welcome to our lecture video on solving. So this is just a quick review video to just sort of get your brain back into that algebra mindset for solving. We're going to just go through a bunch of examples so you can see solving for different equations. So let's jump right in. So let's just briefly talk about solving, what it is and why we're even doing it. What's happening when we're solving? There's a reason we do it, right? So when we're being asked to solve, that means we're being given a mathematical equation. Listen to that word, equation. Okay, an equation has an equal sign in it. An equation represents a relationship between two sides, and it says what's on one side of the equal sign has to be equal to what's on the other side of the equal sign, which sounds super obvious, right? So let's take a look at an example here. So in this example, we have x plus 4 equals 6. This is an equation. We see an equal sign, okay? An equation represents a relationship, and it says that what's on this left side of the equal sign has to be equal to what's on the right side of the equal sign. So x plus 4 has to be equal to 6, all right? And our job is to find the values for that given variable, for x, that make that equation true, that make that relationship hold. Because we have a relationship here, you guys. We have a relationship of equality between two sides. The left has to be equal to the right, okay? This is very different than a mathematical expression, and we'll talk about that in a second. So we need to figure out what value, and in this particular example there is only one value, for x will make that relationship of equality hold, will make that left side equal to that right side, okay? There's only going to be one value that works. So like I mentioned, this is very different than a mathematical expression. And I'm going to just quickly write an example of an expression up here. So for x, that's a mathematical expression. We could literally plug any value in for x, and we would get different values out. So if we plugged x equals 1 in, 4 times 1 is 4. If we plug x equals 2 in, 4 times 2 equals 8. If we plugged x equals 3 in, 4 times 3 equals 12, right? We can plug in any value for that variable x, and we'll get some value out. This is an ordered pair, right? We're making ordered pairings. But we could plug in any value for x in this expression, and we'll get some value out. That's very different than an equation, okay? An equation is all about the relationship. We cannot go willy-nilly plugging in any value for x into this equation. There is only one value for x that will make that relationship of equality hold. And that's why we're solving. That's what we're trying to figure out, okay? So equations and expressions are very different. We're working in very different processes when we're dealing with equations versus expressions. An equation is all about equality, and it will have an equal sign in it, okay? And that's how you can sort of remember it. When you see this mathematical sentence and it's got an equal sign inside of it, oh, I'm dealing with an equation. If there were no equal sign, we'd be dealing with an expression. So we are solving because we need to find the value that will make that equation true, that will make that relationship of equality hold. So in this above example, we're saying what value of x makes the above statement true. That's what we're solving for. We're solving for x. How do we do that? We use inverse operations to isolate the variable and solve. So what does that mean? That just means we want the variable on one side of the equal sign, and we want everything else to be moved over to the other side. That's what you're doing when you're solving, okay? So in this particular example, we have x plus 4 equals 6. We want just x on one side, so we have to get rid of this 4. How do we do that? Well, we're going to use the inverse operation. Since we're adding 4, we want to subtract 4 from both sides. And what we do to one side, guys, we always have to do to the other because, again, we need that relationship of equality to hold. So if we're subtracting 4 from the left side, we better be subtracting 4 from the right. Otherwise, they will no longer remain balanced. So we subtract 4 from the left to isolate x. We must subtract 4 from the right. That's going to clear the 4's, right? 4 minus 4 is just 0, which leaves us with x equals 2 because 6 minus 4 is 2. So we've now solved and found the one variable value, excuse me, for the variable x that will make this equation true. And we can even check if we plug in 2 for x, that would give us 2 plus 4. And does that equal 6? It sure does. So we have solved for the value of x that will make that relationship of equality hold. It will make the left side equal to the right side. Okay, so now let's jump in and do some examples. All right, so here's our first example, negative 23 plus s equals 22. Remember, when we're solving, we're trying to isolate the variable, okay? And we're going to use inverse operations to do so. So that means we want s on one side, everything else moved over to the other. Here we have this negative 23. That negative means that we are dealing with subtraction. What's the inverse operation of subtraction, you guys? Well, that's addition. So we're going to add 23. And remember, we need to make this relationship of equality hold. So if we're adding 23 to one side, we better be adding 23 to the other side. Those 23s will cancel, which leaves us with s equals 45. Okay? So we've isolated s, we've solved for that one variable that will make this relationship true. Let's just double check. So negative 23, if I plug in 45 for s, does that equal 22? And indeed it does. And if you're not sure, you can always plug it into your calculator, okay? So now let's look at another example. So here we have 5x plus 7 equals 37, and I wanted to throw this example in because now we're going to have to take 2 steps to isolate for x, okay? So we're going to have to do 2 inverse operations. So remember, isolating, we have this relationship of equality here. We're saying that 5x plus 7 has to equal 37. So there is some value for x that will make that relationship hold. That will make 5x plus 7 equal to 37, right? The left side equal to the right. So I need to isolate for x. That means I want x on one side, everything else moved over to the other. Okay, I'm going to do that by using inverse operations. First, I'm going to target this 7. Well, if I'm adding 7, what's the inverse operation, you guys? Subtracting. What I do to the left, I have to do to the right because I need to make that relationship hold. These will cancel. Now I'll bring down my 5x. What's 37 minus 7? Well, that's 30. Okay. Now, if I'm looking at my left side, I still have not fully isolated x. Remember, when I'm isolating a variable, that means I just want that variable on one side and everything else on the other. I have a 5 over here with my x, so I have to get rid of that 5. All right, how am I going to do that? I'm going to use the inverse operation. My 5 is being multiplied by x, so I need to divide by it. And what I do on the left, I have to do on the right, okay, to make that relationship of equality hold. 5 divided by 5 is just 1, so those cancel. 30 divided by 5 is 6, so I get that x equals 6 for this example. And again, I could go back and check. So if I did a quick check up here, 5, let me plug in the 6 for my x, plus 7. Does that equal 37? Well, 5 times 6 is 30. Plus 7, yes, it does indeed equal 37. Okay, so that checks. Let's look at another example. All right, here's my third example. I always try and throw in an example with fractions because fractions tend to make people panic, and we just deal with them in exactly the same way that we've dealt with the other 2 previous examples. So don't get nervous when you see fractions, you guys. You're just going to follow literally the same set of steps here. So here we have x plus 1 over 10 equals negative 4 over 5, okay? So I need to find the value of x that when I add 1/10 to it will give me negative 4/5. And I'm going to do exactly the same thing. I need to isolate x, which means I need to move this 1/10 over, right? I need to get rid of it, basically. So how do I do that? Well, what's the inverse operation of addition? It's subtraction. So I'm just going to subtract 1/10 from each side. And guys, if this makes you really uncomfortable, we know these cancel, use your calculator, all right? And how would I plug this into my calculator? I'm going to use parentheses. Whenever I plug in a fraction, I'm going to use parentheses around the entire fraction. So I'm going to hit beginning parentheses, negative 4 divided by 5, end parentheses, okay, minus beginning parentheses 1 divided by 10. All right, that gives me negative 0.9. And if I wanted to, I could even convert that back to a fraction. There is this great button that says math on my calculator. And the second option says that, or the first option says that I can convert it to a fraction, so I just hit that, and that gives me -9/10. So x would equal -9/10 in this case, okay? And I could check that by just plugging -9/10 in to my equation. Plus 1/10, does that equal -4/5? And I'm going to do the same thing. I'm going to do beginning parentheses, -9 divided by 10, end parentheses, plus beginning parentheses 1 divided by 10, and that gives me -0.8. Is that -4/5? Well, I can use that handy math button again, and I can just hit the first option and change it to fraction. Yes, it does. It equals -4/5. Okay? So don't freak out when you see fractions. You're just dealing with them in much the same way. Okay, let's look at another. So in this example, I threw it in because now we have some distributing that we need to take care of first. So here, let's just read this equation. 3 times quantity, 3 plus 6x, and quantity, minus 5 equals 58. Whenever you see parentheses, guys, distribute, distribute, distribute. Before you do anything else, distribute first. Okay, so I need to distribute this 3 through to each term within those parentheses. So 3 times 3 is 9. Plus 3 times 6x gives me 18x. I can't forget that minus 5 equals 58. And now I'm going to combine like terms. I have two number terms here. What's 9 minus 5? Well, that's 4. So I have 4 plus 18x equals 58. Now I can start solving using inverse operations. Now I can start isolating that x. So what I'm going to do first, I'm going to subtract 4 from both sides. Okay, and I'm going to come up here. So that will give me 18x equals 54. Okay, remember I want to isolate x completely, so I need to get rid of this 18. All right, when I say isolate x, that means I want x by itself. So how am I going to get rid of that 18? Well, here 18 is being multiplied by x, so I'm going to divide it. That's the inverse operation. Okay. And I have to, of course, do it to both sides. That gives me x equals 54 divided by 18. If you might just know it. If you don't, you plug it into your calculator. 54 divided by 18, and that gives me 3. And I would go back and plug it into the original equation. And whenever you check, you guys, you always go back to the original equation and plug in for x equals 3. I'll let you guys pause this video and do that on your own. Okay, let's hop to the next example. All right, so this is our last example. I wanted to show you guys an inequality because you're going to see them on your homework. You might see them on a test, or you might see them as the semester rolls down the road, and I didn't want you to get nervous when you saw it, okay? We would deal with this much the same way that we would deal with an equal sign, okay? We still have a relationship here. Only instead of our relationship being that of equality, we now have the left side. The relationship is that the left side has to be bigger than the right side, okay? So we're going to deal with this in the exact same way, only instead of using an equal sign, we're just using a greater than sign. So let's just read this equality first. Y minus 9 is greater than -16, okay? That's how you would read this. So there are values, and here they're going to be multiple values, okay, for y that will make the left side greater than the right side. But we're going to solve this in much the same way. So we want to isolate y, right? Which means we need to get rid of this -9 over here. Well, how do we do that? We just use inverse operations. So I'm going to add 9 to both sides. All right, this cancels. And now I'm just literally rewriting it and bringing, much the same way I'd bring down my equal sign, I'm just bringing the greater than sign down. And -16 plus 9, another way to think of that is +9 minus 16. Okay, you can think of it either way. But if you don't know that, you could always plug it into your calculator if you need a little help. That would be -7. So this says that y is greater than -7. And that is the answer to this problem. You don't have to go any further with it. But I do want you to just take a second and think about that. That means that any value of y that's greater than -7 will make this relationship true. So let's think about that for a second, okay? So let's think of a value that's greater than -7. Let's say y equals 2, right? If you think about a number line, 2 is definitely greater than, bigger than -7, right? It's definitely to the right of it. So if I plug in 2 for y, 2 minus 9, is that greater than negative 16? Let's see, 2 minus 9 is negative 7, and negative 7 is for sure greater than negative 16. So the inequality just changes the relationship, but you're still solving it in the same way. This inequality is just telling us that, well, yeah, this is our solution, and it's telling our solution is that any value of y that's greater than negative 7 will make this relationship true. It will make the left side greater than the right side, okay? So an inequality is just another type of relationship, but you're still trying to figure out what value or values are going to make that relationship true, all right? So I'll pop some more examples onto the end of this slide that you can try this presentation so that you can try them on your own. And please feel free to reach out if you have any questions by posting in the discussion forum of our Blackboard course. But I think you guys will do great with this. All right? Okay, bye. So here are a few examples for you guys to try on your own, okay? Please feel free to go back and rewatch this lecture, and as you're doing each example, watch the examples that I did so you can use the same sort of logic to walk through these. If you have any questions, remember, post them in the discussion forum under course questions, and I'll respond to that, and that way everyone will benefit from the answer that I give, okay? All right, good luck. I know you can do it. Have fun. Bye.